In this lesson, we're going to solve quadratic equations by using square roots. But before we do that, we're going to go over some properties of square roots and then practice simplifying. So right here I have listed properties of square roots. We have the square root of a times b. So if you have a product underneath a radical, you can split this up as the square root of a times the square root of b. Similarly, if you have a square root of a fraction, you can split it up as square root of a over square root of b. And you can also use these properties in the other direction. So if you have the square root of a times the square root of b, you could rewrite the expression as the square root of a times b all under one radical. This example says to simplify the square root of 80, what we're going to do is we're going to break down 80 using a factor tree. So first I broke down 80 as 2 times 40, and then we'll keep going. So let's rewrite the square root of 80 as a product of all of its prime factors. So instead of root 80, I have this written as the square root of 2 times 2 times 2 times 2 times 5. Because we have a square root, we're going to pull our factors out in pairs. So this first pair of 2's, we're going to pull them out and it's going to become just 1 2 on the outside of the square root. We're going to do the same thing with this other set of 2's. When you pull a pair out, they turn into just one of them. And then since we just have the number 5, that will stay under the radical. So at this point, we're just going to multiply these together to get 4 root 5. So here's our final answer. So one other thing we could have done is, see how I have 2 times 2? Really that's 4, and we know that the square root of 4 is 2. Same thing, this is also 4, so the square root of 4 makes another 2, and then you multiply those to get 4 total on the outside, root 5. The next example says 3 square root of 5 times the square root of 5. So I use the properties of square roots to rewrite both of these square roots as one square root, and then the 5 and the 5 are both multiplied underneath it. At this point, you can think of this as 25, and the square root of 25 is 5, or you can also think of it as you have a pair, and they come out of the square root, making just one of them on the outside. Either way, you end up getting 3 times 5, and there's no longer a square root because nothing's left underneath it. So our final answer is 15. For part C, we're going to break down 6 and we're going to break down 21 to the prime factors. And next, we're going to write all of these factors under one big square root. So again, we're using the property of square roots to rewrite this expression as one big square root and all of the factors underneath it. Next, we're going to pull out the pairs. So you have a pair of 3's. When you pull them out in the front, you only have 1 3, and the 2 and 7 stay on the inside of the square root. So our final answer is 3 square root of 14. So for part D, we're going to rewrite this. So according to properties of square roots, we can rewrite this as the square root of 7 over the square root of 25. In the denominator, the square root of 25 is 5. And since 7 is not a perfect square, we're going to leave our answer as the square root of 7 over 5. So the next concept that goes with simplifying radicals is rationalizing the denominator. So I have this written out. It says radical expressions at times are easier to work with if the denominator does not contain a radical. The process to clear the denominator of a radical is referred to as rationalizing the denominator. So in the denominator, if you have a square root of some number, in order to rationalize it, we're going to multiply the numerator and denominator by that same expression. Another case would be if you have a denominator that has something of the form a plus the square root of b. In order to rationalize it, we're going to multiply the numerator and denominator by what we call the conjugate, which is a minus square root of b. So for this first example, we have a square root of 2 in the denominator. To rationalize the denominator, we're going to multiply this fraction by root 2 on top and bottom. Now that we're multiplying fractions, we multiply across the top and across the bottom. So when you multiply across the top, you just get 5 root 2. When we multiply across the bottom, we're going to rewrite this expression as the square root of 2 times 2. At this point, you can either think of this as 4, so the square root of 4 makes 2, or you can say you have a pair and they come out and become just one of them. So that makes our final answer 5 root 2 over 2. And you'll notice from the original problem to the answer, by rationalizing the denominator, we no longer have a radical in the denominator. For this next example, we're going to rationalize the denominator. So right now we have 3 minus the square root of 5. So what we're going to do is we're going to multiply by 3 plus the square root of 5. So this expression is the conjugate of this one. You leave the 3 the same, you rewrite the square root, but then you use the opposite sign. So at this point, we're going to multiply the fractions. To do so, we're going to multiply across the top, and we're going to multiply across the bottom. To multiply across the top, 1 times any expression is just itself. So in the numerator, you just get 3 plus the square root of 5. To multiply the denominators, we're going to FOIL. So we're going to do first, outer, inner, last. When we multiply the first, it's going to be 3 times 3 makes 9. Next, we multiply the outer terms. So we're multiplying 3 times positive root 5. Next, we're going to multiply the inner terms, so the two terms on the inside. We multiply those together and we get negative 3 root 5. And now we multiply the last terms. Negative root 5 times positive root 5 makes negative square root of 25, which is negative 5. Now, if we look at the denominator, these two terms, the outer and the inner term, cancel out. So we're just going to combine the 9 and negative 5 to get 4. So our final answer is 3 plus the square root of 5 all over 4. Just want to make a quick note, you could also rewrite the expression as 3/4 plus the square root of 5 over 4. So either answer is correct. For this next example, we're going to do the same thing. We're going to multiply by the conjugate of the denominator. So right now we have 7 plus the square root of 2. The conjugate is going to be 7 minus the square root of 2. So at this point, we're going to multiply these fractions. To multiply the numerator, we're going to distribute the 3 to both of these terms. So on top you get 21 minus 3 square root of 2. In the denominator, to multiply these, we're going to FOIL again. So 7 times 7 is 49. The outer term is going to be 7 times negative root 2, so you get negative 7 root 2. The inner term is going to be the square root of 2 times 7. So I have positive 7 root 2. For the last term, we're multiplying positive root 2 times negative root 2. So that just makes negative 2. Your outer and inner terms cancel out. And finally, 49 minus 2 makes 47. So I'm going to leave the answer just like this, 21 minus 3 root 2 all over 47. So now we're going to solve quadratic equations using square roots. For this first problem, just like any equation, first we want to isolate the variable, so the first step is we're going to subtract 5 from both sides. Next, to keep isolating the variable, we're going to divide both sides by 3. Okay, so now we have x squared equals positive 12. To get the x by itself, we're going to take the square root of both sides. If you'll notice, there was no square root in this problem, but in order to solve for x, we brought a square root into the problem. So the general rule is if you bring the square root into the problem, you're also going to include a plus or minus. So now the square root of x squared just makes x. And over here we have plus or minus the square root of 12. At this point, let's break down 12. And I'm going to stop here for a second. 12 is 3 times 4. I could keep going and break 4 down to 2 times 2, or you can stop here and say the square root of 4 is 2. So you end up getting plus or minus 2 square root of 3. Remember, this means that there's two answers. You have positive 2 square root of 3, and then your other answer is negative 2 square root of 3. For this problem, we're solving for x. To do so, we need to get rid of this 1/5 first. So before we do anything, we're going to get rid of the 1/5 by multiplying both sides by 5. When you multiply the left side by 5, these 5s cancel out. And on the right side, 7 times 5 makes 35. Next, to get the x by itself, we're going to get rid of the square. So we're going to take the square root of both sides. And again, since we brought the square root into the problem, we need to include a plus or minus as well. So the square root and the square, they undo each other, and you're just left with x plus 3. And on the right side, we have plus or minus the square root of 35. Our very last step to get x by itself is we're going to subtract 3 from both sides of the equation. And over here, when you write your answer, you're just going to put negative 3 plus or minus the square root of 35. So it's important to note that this is just a constant. Your answer is negative 3 and then plus or minus root 35. And remember, this represents two answers. It's negative 3 plus root 35 is one answer, and the other answer is negative 3 minus root 35. For this next example, our first step is going to be divide both sides by 3. At this point, we're going to square root both sides, and make sure you write plus or minus. The square root and the square cancel out, so you just get x equals. And on the right side, we're going to split the fraction up. So we're going to go square root of 4 over the square root of 3. So now we have plus or minus 2 over root 3. So at this point, we're going to rationalize the denominator. So we're going to multiply the numerator and denominator by this square root. So we're going to multiply across the top and across the bottom. So across the top, we get 2 root 3, and in the denominator, the square root of 3 times the square root of 3 is the square root of 9, which equals just 3. So here's our final answer. It's plus or minus 2 root 3 all over 3. Okay, for this example, we have 2x squared equals 1/9. So we need to start by getting rid of this 2. So normally we would just divide both sides by 2, but because we already have a fraction, instead of dividing by 2, let's multiply by 1/2 to both sides. Okay, so I wrote this out. We have 2x squared and we're timesing by 1/2. And again, remember, mathematically that is the same as dividing by 2. And we're going to do the same thing over here. We're timesing 1/9 by 1/2. So these 2's cancel. And over here, when you multiply across the top and across the bottom, you get 1 over 18. Okay, at this point, we're going to take the square root of both sides. Don't forget your plus or minus. So on the left, the square root and the square, they cancel out, so you just get x equals. And over here, I'm going to split the fraction. So we're going to go square root of 1 divided by square root of 18. Okay, so on top, the square root of 1 is 1. And remember, 18 is 9 times 2, so the square root of 9 makes 3. So at this point, we have 1 over 3 square root 2. Last step, we don't want the square root in the denominator, so we're going to rationalize by multiplying the top and bottom by root 2. So when we multiply across the top, we get square root of 2. And in the denominator, you have 3. Root 2 times root 2 is just 2. So our final answer is plus or minus the square root of 2 over 6. Thanks for watching, guys!